Good morning, children, and welcome to the online classes. In my previous class, I had explained to you highest common factor, the HCF, and we had done two methods. The short division method, you can call the short division method also the common division method, and we had done the prime factorization method. Now I'm going to do least common multiple also. We'll finish up with that, and then we will start on the exercise. Now when we are finding the least common multiple or LCM, again we are only targeting two methods. There's no point having 4 or 5 methods. You can refer to the textbook and see how those methods are. But what I am teaching you is just particularly two methods which you actually need to know in order to solve least common multiple or highest common factor. Now the first method that we are coming across here is the same method that we used for HCM. But the concept and the method is different. There also we have the prime factorization method. So prime factorization method. Today's lesson is also going to be an explanatory lesson. There are not going to be any sums that you have to do. But you have to understand the explanation. Once again, it's better you have earphones on or headphones on, so you have my undivided attention and you are able to understand the explanation very clearly. Now let's take numbers. Suppose I have to find the LCM of 3 numbers through the prime factorization method. Suppose those numbers are 12, 36 and 48. Just like HCF, the prime factorization method is exactly the same. The only difference between HCF and LCM is at the end how do you get your answers, or at the end how do you solve to get highest common factor or least common multiple. The method is exactly the same. Prime factorization method, again I've got 3 numbers and again I have to factorize them. Now when I'm factorizing them, I have to remember I only use prime numbers. So 12, and I start factorizing 12, only using prime numbers. 1 is not a prime number. The first prime number 2. Does 2 go in 12? It ends with 2, yes. 2, 6 are 12. Does 2 go in 6? Yes. 2, 3s are 6. Remember children, you take a prime number, you start with the first prime number and start factorizing, and you go on factorizing it till you cannot factorize it anymore. When you cannot factorize it anymore, then only you go to the next number. Otherwise, you keep using that particular prime number till it cannot be used anymore. Now, when I come to 3, I know now I cannot divide that by 2. So, I go to my next prime number, and that is 3. 3 1s are 3. And 12 has got factorized. Then I come to 36. And I start factorizing that too. Starting with the first prime number, 2. 2 divides it because it's ending with 6. 2 1s are 2. Carry 1. 2 8s are 16. Now here I would like to remind you, try to keep a little space between your numbers so that you can write the carry over onto the next number. So you don't get confused. You can either write the carry over with a pencil, but then you'll have to transfer from pen to pencil, pen to pencil. So it's okay if you use a pen also. Does 2 divide 18? Yes. 2 9s are 18. Now 2 does not divide 9 anymore. So the factorization of 36 with 2 is over. I go to my next prime number. What is my next prime number after 2? 3. 3 3s are 9. And we all know that 3 1s are 3. And 36 has got factorized. Let's go to the next number, 48. Remember, we are doing the prime factorization method. Prime factorization method. Does 2 divide 48? Yes, because it's ending with 8. So 2 2s are 4, 2 4s are 8. Does 24 divide by 2? Yes, it's ending with 4. So 2 1s are 2, 2 2s are 4. Does 12 divide by 2, yes, 2, 6 are 12. Don't jump to 3. As you see 6, you want to divide by 3. Don't do that. You are still to divide by 2 because 2 will go in 6 also. So don't jump to the next prime number till you have finished with the previous prime number. So 2 3s are 6. Now I cannot divide anymore by 2. So my next prime number is 3 and therefore 3 1s are 3. I have factorized all the numbers. Just like my previous video when I was teaching you HCF using the prime factorization method. There also we had factorized each number separately. But there we had taken the common numbers. Here it is a little different. So let's see what's the difference. So I take 12. Now I don't have any space here. So that is why I am writing it that side of the board. But you will be writing it under the factorization of the 3 numbers. So 2 is factorized as 2 into 2 into 3. 36 is factorized as 2 into 2 into 3 into 3. And 48 is factorized as 4 2's have been multiplied together. So 2 into 2 into 2 into 2. Always count and clarify or make sure that you've written the exact number of that particular digit that many times. Because many times you multiply by 2, you go and put an extra 2 and your answer will be wrong. So 1, 2, 3, 4. 1, 2, 3, 4. And last is 3 multiplied by 3. Now this is just like HCF. Exactly like HCF, the prime factorization method. Same method. Both will be more or less common. But what you have to do at the end is very important. Now here I have factorized it and I am finding LCM, not HCF. So I do not circle the common ones. In HCF, we circle the common ones. So what do we do in LCM? In LCM, we look at what digits are there in all of them. There are only 2 digits being used in all these 3 numbers that we have factorized. The digit 2 or the number 2, the digit 3 or number 3. So only 2 and 3 you can see in this area. Now you have to ask yourself, where is the maximum number of 2's? 1, 2, only 2, 1, 2, only 2, 1, 2, 3, 4. This is the maximum number of 2's. So I make a box over it. Now I go to the next number. What all else do I have? I have 3's. Where do I have the maximum number of 3's? Here 1, here 2, and here also 1. So where is the maximum number of 2's? The maximum number of 2's is here. Sorry, where is the maximum number of 3's? The maximum number of 3's is here. Here there is 1, here there is 1, but here there are 2. So I'll make a box around the maximum of that particular number. 2 is given 4 times here, so I made a box around this. 3 is given 2 times here, so I make a box around this. The maximum has to be made a box around. So there's one way that you can keep reminding yourself is that in HCF you circle the common ones, you make circles, but in LCM you make boxes, and boxes around the maximum ones. So the LCM would be, or the least common multiple. I take all the 2's which I have made a box around. There are 4 2's, and I take all the 3's. There are 2 3's that I have made a box around, and that's my answer. Multiply all the 2's and get one answer. 2 2's are 4, 4 2's are 8, 8 2's are 16. Make a line like this and write 60. 3 3's are 9 and write 900. What comes between them? This multiplication sign that was between all the 2's and all the 3's. And then I multiply to get my final answer. 9 6 are 54. Carry 5. Make a small 5 here. And 9 1's are 9 and 5, 14. So my LCM is 144. This is exactly the concept and method of finding the least common multiple using the prime factorization method. It's just like HCF, the same factorization we did in HCF, The same we wrote all the factorized numbers for all the numbers that we were factorizing, but in HCF we circle the common ones. In LCM we make boxes around the maximum ones, multiply all of them, and I get my least common multiple. Remember, this will be sent as a snapshot. It has to be copied into your notebook in a blackboard.